Okay, so we're going to solve an equation with logs. Oh. Right?
Oh.
So what do you do first?
E to the stuff.
Do the stuff?
Both sides.
What do you mean do the
E
stuff?
to the stuff.
Oh, e to the stuff. I would advise against that personally. It's not that it's wrong, just that it's annoying.
Can you
Because
do
you
that?
have to.
So if you do e to the stuff, you have to remember that it's e to all of this junk.
So you'd have to FOIL the E into it? No.
So you'd have to use some kind of exponent rules or something.
Oh, you'd have to do.
You can't just slash out the logs.
Right, you'd have to add.
Right, so if you did e to the stuff both sides, you would get e to the natural log of w squared minus 4 minus the natural log of w minus 2 equals 4.
Which doesn't.
And then on this side, you can't slash the e's and the logs because they're not an inverse and a function. They're not a function and its inverse applied right next to each other. So what you could do is you could use an exponent rule. Right, and say, okay, so here I have e to the something minus e to the something. So that's like e to the first thing
Oh, divided by the second.
divided by e to the second thing.
And then it's W squared minus.
And then you could slash out the e to the ln. And so in the end here, you'd get w squared minus 4 over w minus 2 equals 4.
Which one of them is going to cancel out?
And then you could factor the top and drop a w minus 2. And get w plus 2 equals 4 and solve that. Solve that.
So what's the other way?
Yeah.
So the other way the way I would suggest is that you look at this stuff here and you say, that's a difference of logs. And I have a log rule for stuff like that. So instead of using an exponent rule later, you can use a log rule now.
And
that'll get you to, you have the natural log of w squared minus 4 over w minus 2 equals the natural log of 4.
Then do E to this.
And then do e to the stuff.
And then you get the same thing.
Right, and then the logs just drop straight off, and then you're at w squared minus 4 over w minus 2 equals 4. And you didn't have to think very hard about exponent rules.
Yeah, the first one's a little bit more subtle.
Could you add the natural log of w minus 2 in the very beginning to the other side, and then take e to the stuff, and then just kind of like cross off
Oh,
their
yeah, you
natural
could have done
logs?
that too, huh?
You could add this to that side,
Right.
and then e to the stuff everything.
Yeah.
But you will still have an exponent rule that you have to deal with.
What do you mean?
So if you did that, you would do, for yet a third approach, you would add this log of w minus 2 to both sides, right? So you would get natural log of w squared minus 4 equals the natural log of 4 plus the natural log of w minus 2.
And then you have to do the.
And then if you e to the stuff everything, so if you e to the stuff, you get w squared minus 4 equals e to the natural log of 4 plus the natural log of w minus 2. And then you'd have to use an exponent rule on that stuff. Or you could use a log rule first for yet a fourth approach on the right-hand side, and get natural log of w squared minus 4 equals natural log of 4 times w minus 2. And then e to the
Oh,
stuff.
because it's added.
But either way, you need either a log rule or an exponent rule. I don't care which one you use, but you definitely need one or the other.
Didn't do that, and still have to calculate it.
Yeah, so that's probably a miracle about 2s and 4s.
Yeah.
More than anything.
So is that totally simplified then, the log rule when you did the middle? Like that's not very about, is that done?
No, that's not quite done. So if you want to finish any one of these off, you're always going to get to this spot or to this spot with the w minus 2 multiplied to the other side. So if you factor and cancel, factor and reduce, maybe is a better word. So if you factor and reduce, you get W plus 2 equals 4. And you'll subtract 2 from both sides, so you get W is 2. And then really you should plug that back in at the beginning.
I got that too, but you showed me how to do it a totally different way.
Yeah.
Not totally different, but
Well, any one of these. So if you take that W minus, or W equals 2 at the end and plug it back in at the beginning, you get the natural log of 0, right? Which is, natural log of 0 is, how many e's you multiply together to get 0?
What?
Okay, so I'm asking about the natural log of 0, right? If this was a number, e to that number would equal 0.
It's not 0.
How many e's do you multiply together to get nothing?
You don't multiply.
You don't.
Even if you put 0.
This thing's not a solution. It looks like a solution, but it's not. The answer to this problem is there aren't any solutions.
Wow. So the one solution is extraneous.
Yeah, the one solution at the end here is extraneous.
oh, so that's the answer is that there is no answer.
Yeah, no, the answer is there are no solutions.
Okay.
That's not quite there is no answer, right?
That is still an answer.
That's this function right
Does
here
not equal-
does not hit that function right there. See that? Which is sometimes the thing you're looking for.
And you tested that by plugging it back in.
Yep, so when I got to the end, right, I just went to back to the beginning and plugged it in to see if it worked. And it doesn't even make any sense, right? So obviously it doesn't work. You guys know to do that, right? When you get to the end of a problem, you should always take the answer at the end and plug it back into the beginning. See if it works. Right? That's a cheap and easy way to earn a couple of points on the exams too. Right? Because you take it, you at least try to plug it back in. If it doesn't look like it works, you're right. I'm a bit confused. It doesn't seem like this is working. That's actually worth some points, right?